Miscellaneous exercise on vectors. I'm taking up the questions you all said you have problem with. First is question number 4. If vector A is B plus C, then is it true that modulus of A will also be equal to modulus of B plus modulus of C? Justify your answer. So this is not always true, children, and how are you going to present it is, given that vector A is B plus C, then we have to talk about its modulus. So their modulus of the two sides will also be same, and to be able to apply this dot products formula, we are squaring it. We are considering the square of the modulus. Okay, so square of modulus of A is equal to square of modulus of B plus C vector under the given condition. Then we know that modulus or square of any vector is its dot product with itself. So we've considered B plus C dot B plus C. Next we'll distribute, dot product distribute, so B dot B, B dot C as well, then C dot B and C dot C. Okay, then again by the same property, B dot B will be replaced by modulus of B square, C dot C will be replaced by modulus of C square, and as I've written here, we know dot product is commutative, so we can write this also as B dot C. So B dot C, B dot C add up to give you 2 times B dot C. Okay, now in our question we had only modulus of B plus modulus of C there. Okay, so this dot product also I'm expanding by its formula. We know B dot C is modulus of B into modulus of C into cos of theta, if theta is the angle between these two vectors. Now we know about cos of theta. Modulus of cos of theta ranges from -1 to 1, we can say. Okay, so whatever the case, since we are talking about modulus, so modulus of cos theta is always smaller than 1. The maximum value cos theta can take would be 1, right? Maximum value इसकी 1 है, तो 1 के अलावा कोई भी और वैल्यू, कोई भी और एंगल के लिए कुछ भी वैल्यू होगी, this whole expression will become smaller than what will be the value for maximum value, that is 1. So in the next step what we have done is we have replaced cos of theta with 1, we can say out here. Okay, if you compare these two equations, this one modulus of B square, modulus of C square same, 2 modulus of B, modulus of C, everything same. यहाँ cos theta है और यहाँ हमने 1 consider कर लिया है, तो 1 उसका maximum value है, तो बाकी कोई भी और थीटा होता तो ये एक्सप्रेशन पहले इस वाले से छोटा होगा, तो the sign of equal to changes to smaller than. You must have done these type of inequalities in solved examples, you must have seen. Okay, so there is this inequality also there. Hence, so under this condition, that cos of theta compared to 1 is always a smaller modulus of cos theta. So if I'm removing this cos theta from here, this whole expression becomes smaller than this expression. Okay, अभी ये आइडेंटिटी से मैच कर रहा है आपका a square plus b square plus 2ab, so we can write it as a plus b whole square, that is modulus of b. Modulus are real numbers only. Okay, so we can apply the algebraic identity here now. So modulus of b plus modulus of c is whole square, so that is why taking root, modulus of b becomes smaller than modulus of b plus modulus of c in general. Okay, so यूजुअली ये मॉडुलस जो है इस मॉडुलस से छोटा होगा, एट द मोस्ट इक्वल टू हो सकता है. इक्वल कब होगा? व्हेन दिस थीटा वुड बी 0, बिकॉज cos 0 वुड बिकम 1. Okay, so the question was, these are equal, but these are not always equal. In general, that is not true. They are going to be equal only under the condition angle between the two being 0, or maybe we can say the vectors being collinear. Okay, so that way you're going to present it. Okay, next problem was, someone said 8th one there, that show that the points A, B, C are collinear, and then you have to find the ratio in which B divides AC. Okay, through vectors, of course they should write, because यहाँ पे already vector का chapter चल रहा है, तो they won't, but in exam they would say mention that through vectors verify that A, B, C are collinear, and find the ratio in which B divides AC. Even if not said, children, then you know that in your courses vectors, you should always do it using vectors. Obviously आप यहाँ पे अब coordinate नहीं दिखाओगे, right? So we'll convert it to vectors. This is the case like you are given coordinates of A, B, C. कोऑर्डिनेट्स में एक्स वाई जेड कोऑर्डिनेट्स में आई जे के लगा के पोजीशन वेक्टर मिल जाता है. सो आई हैव प्रेजेंटेड इट इन द फॉर्म ऑफ पोजीशन वेक्टर ऑफ ए, पोजीशन वेक्टर ऑफ बी, पोजीशन वेक्टर ऑफ सी नोन. Okay, now there are two ways of doing it. Maybe a few students might first prove it that A, B, C are co-linear and then proceed to apply section formula, but you can cut it short. उसमें hence word नहीं है, तो आप चाहो तो दोनों proof at one go आ जा रहे हैं. आपका ratio भी निकल जा रहा है and वहीं से आपका collinearity भी verify हो जा रही है. So I have done it that way. I've cut it short. Let me explain. Say that A, B, C are, suppose they were collinear, then ratio is what we had to find. We don't know it, so I've assumed that ratio as lambda is to 1. Alright, then position vector of B can be obtained by section formula as lambda into position vector of C plus 1 into position vector of A upon lambda plus 1. That happens by section formula. Okay, now collecting all your i's, j's and k's together. So from here 11 lambda plus 1, and from here 3 lambda minus 2, 7 lambda minus 8. These are your three coordinates which should be equal to, position vector of B was already known. Okay, so just for comparison I have also mentioned it as 0 j out here. Okay, now we'll compare both the sides. If two vectors are equal, the I, J, K components are equal. So convenience हमारी calculation convenience 0 के साथ है. So I have taken this equation first. Okay, so 3 lambda minus 2 upon lambda plus 1 will be equated to 0. On the left hand side, this component is 0. So from here we evaluate our lambda as 2 upon 3. Okay, so what I've done next is I've put this value of lambda here as well, for x coordinate and for y coordinate, and checked whether they are coming equal or not. So putting this value of lambda in I component came out to be 5, was as 5. Then k component, put it here, is coming as minus 2, was given as minus 2. So अगर ये कोलिनियर नहीं होते तो ये लैम्डा बाकी दो कोऑर्डिनेट्स को सेटिस्फाई, बाकी दो कंपोनेंट्स को, आई एंड जे कंपोनेंट्स को सेटिस्फाई नहीं करता. Okay, so after taking out this lambda and checking कि it is also satisfying the other remaining two components, this is only possible if A, B, C were collinear. Okay, so I have cut it short. मैंने collinearity अलग से नहीं check की है, वो आप कर सकते थे taking out vector A, B, B, C, A, C कुछ भी, one vector lambda times the other, या proportion दिखा के. There are so many techniques for proving vectors collinear. So I have done it क्योंकि मुझे already lambda ratio निकालनी थी, तो मैंने वही 2 in 1 कर दिया. रेशियो निकाल के उसी की हेल्प से वेरीफाई कर लिया कि ये कोलिनियर भी हैं, क्योंकि वो रेशियो बाकी सारे कंपोनेंट्स को एक से हमने निकाली एंड बाकी कंपोनेंट्स को सेटिस्फाई कर रही है. ओके, हेंस ए बी सी आर कोलिनियर विद बी डिवाइडिंग ए सी in the ratio 2/3 can be written as into 3 into 3. So 2:3 is the required ratio.